In this lesson, we're going to look at applications of sinusoidal functions. When we're looking at these, we're now looking at a problem where we're given data, and we're going to have to come up with a data table and then use our graphing calculators to get the regression function to find any other information we're looking at. So let's take a look at this example here. It says a mass is suspended by a spring and is in a resting position 0.50 meters above the table. So we can see that drawn in right here. The mass is pulled down 0.4 meters and then is released. The following information is obtained. It takes 1.20 seconds for the mass to return to its lowest position. The mass reaches a maximum height of 0.90 meters. So we can see the spring is at a resting position right now, and it'll go down and back up and down and back up and down and back up. However often they're explaining here. So pulled down 0.04 meters, that would be about here, because this is 0.5, so not all the way. And then released, it takes 1.2 seconds for the mass to return to its lowest position, which is right here at 0.40 meters, if that's that distance here. And then it reaches a maximum of 0.9, so it's going to go up to 0.90 meters, right? So if we want to figure out the sinusoidal regression here, what we should do, like I was saying earlier, is create a table of values for those key points. Okay? So what is that exactly that we're graphing? That's the other piece that we need to know. Well, it appears that our two variables are time, measured in seconds, and our distance, measured in meters. So if we have a little data table here, we can see at the starting point how far we are. So that's at 0 seconds, and I'm just going to put 0.0 because it seems like we have our 0.00, our time measured in 2 decimal places. Okay, so we know that point. We know what's happening at 1.20 seconds, which is right at the end here. I'm not going to put the S there so we don't think it's a 5. And we know kind of what's happening in between, right? Halfway in between. So halfway in between are 1.2 seconds, so that would be 0.60 seconds. So at the starting point, how far are we actually above the ground? We know that we've stretched it down 0.4, but it's not really intuitive here that we need that what this distance is in between. So that distance in between where the spring is sitting at its resting point is actually at 0.10 meters above the table. So that when it's at its highest point, right, that's at 0.90, and then back down to its lowest point, 0.10. So those are 3 key points, but that's not enough for us to get a sinusoidal regression. So what's happening in between all of that? Well, we know that halfway in between is our resting point, because you can see from here, this distance is 0.40. This distance is 0.40. So that's like our A value is 0.40, right? And then this midway point is where we have our resting point, right? And that's like our D value, 0.50. So that's in between those. So this would be a time of 0.30 here, 0.30 here, and then we would have 0.50 for in between. Now this is more than enough information to get us our sinusoidal regression. Okay? So in terms of our parameter method, if we kept going with this, you can see that it would be a bit more challenging to get your C value, right? And then your B value as well. Okay, so let's go ahead and use your regression function. So it says determine the sinusoidal equation. So we're going to go ahead and put this in our calculators. So clear everything out that you have in your calculator from whatever you were working on last. Stat 1. Okay, so here I've got 0, 0.3, 0.6, 0.9, 1.2 for my times, and then for my distances I've got 0.1, 0.5, oops, I made a mistake there, 0.5, 0.9, 0.5, and then back to 0.1. So if we use that into our sinusoidal regression, stat, calc, we're going to go up to sinusoidal regression. We can see our regression function has an a value of 0.4, b value of 5.24, c value of negative 1.57, and a d value of 0.5. So if we're rounding everything to 2 decimal places, it would look like this. Y equals 0.40 sine 5.24x minus 1.57 plus 0.50. Alright, now we can use our function to answer B. It says when will the mass be 0.75 meters above the table for the first time? So we can use our intersect here. We would have a y value, because that's what this is, a y value, and then point of intersection. So graph y equals 0.75 meters, and then use second, trace, intersect. Let's try that out. So under y equals, we've got, oh, I need to put in my regression function first. Vars 5. We didn't even look at the graph yet. So trace and zoom, I didn't hit zoom 9. So there it is. Alright, now that that's in there, let's jump in again there. So now that that's in there, we can put in the 0.75 and hit trace. There it is. And we want to know for the first time, so second trace 5. Make sure you move your cursor over so it's closer to that first point. Enter, enter, enter. And we get that that's at 0.43 seconds. So 0.43 seconds is when it's going to be 0.75 meters above the ground for the first time. So all the questions that you're going to be getting are going to look a little bit different, but the same initial scenario. You're going to have a situation, you're going to set up your 3 points that are usually the easiest, which is your beginning, middle, and end, and then you're going to deduce from what you have those in-between points, and then from there you should be able to get your regression equation and then figure out whatever you need from there. Thanks for joining me for today's lesson.